Three, two, one. Yeah, I'm back up, bro. I'm back up. Nothing happened. What was the question? What was the question?
Yeah, the question is, I'm gonna send you the question.
And you were talking about like Facebook and stuff. So you got Facebook so far? Like you've been interviewing with them, and where else?
I did Instagram, which is Meta.
This is Facebook still. Okay.
Yeah, and I also did Pinterest, which was pretty easy. It's very easy to
Oh shit.
a bunch of startups in the valley. One of them was what's that company called? Together AI. UI. That's not a startup. They're in accounting.
Accounting.
Yeah.
What are you working for? QuickBooks now?
No, UI is like
Oh.
accounting on steroids. Yeah. Yeah. But they have like crazy amount of revenue. Like 27 billion
Oh shit. All right.
ARR. Yeah.
You should get in there and then put me in the doghouse, and then I'll work like 100 hours a week, like Elon's Twitter boys, and then like get up to speed quickly. You know what I'm saying?
Nah, dude, you can do it. You don't need. You don't need. Forget how you call it. Do your own thing.
That's why I kind of took the content route. It's because like yeah, like I'm spending like all this time like doing all these questions, and then like it. I wanted to at least amount to something. Okay, so subsets. Okay, so given an integer array, DOMs are unique elements, return all the possible subsets. Okay.
I'll share your video link. Please, so I can also whiteboard with
Oh, the whiteboard link.
yeah.
Is this shareable? Oh, shareboard. Copy link.
Yeah.
I didn't know you could share this. This is my first time doing it live with a double team.
Product engineer. Yes.
Product engineer.
Leadership roles. So I think it's kind of cheating, you know, because they never ask me any hard questions.
Okay, so we need to get a nums unique elements. Okay, so all the possible subsets, the power set. So the solution must not contain duplicates. Okay, so that means we have to return some sort of set, so that way it doesn't return duplicates. And then return.
Wait, this is a medium, but this is actually kind of hard.
Is it?
Yeah, they say it's medium, but like this is for intuition, right? It is kind of hard. So don't feel that you don't get it at first. You just have to do it.
Okay, so I'm gonna start by let's see if there's like some easy way to do it. So I'm gonna say my search is gonna be
No, don't.
no searches.
Just, no.
Is it logic only?
Yeah, ask me questions.
Okay.
Go on your whiteboard and ask anything you want.
So
How do you think a brute force? Let's talk through it. Like, how do you think a brute force solution would be? Like, do you understand? Look at the examples. I'll give you another hint. Look at the examples, and you'll see that this is a classic. If you have looked at advanced functions or computing functions in school, this is a classic example of that. So
yeah.
1, 2, 3, and then 1 by itself is set, 2 by itself is set, 3 by itself is set, and then you get 1, 2, and then you get 3, and then you get 1, 2, 3.
Yeah, so what I do is this. I would go brute forcing, I'd go double for loop. Start with one number and combine it with each other element. Skip itself. So I go 1, 2, 1, 3, and then it would be 2, 1, 2, 3. Then it would be 3, 1,
Do you have
3.
like some sort of, by the way, do you have like some sort of stylus or something? How are you?
Oh, I clicked this.
Oh yeah. Oh shit. You
You
just doing it with
you get
mouse?
tools.
Holy shit.
Yeah, I've been doing it with my mouse. Yeah,
What a guy. What a
bro.
guy.
Like, dude, I'm ghetto, bro. I don't have like fancy tools and shit like you guys.
No, I don't have it, but like look.
All these top tier devs have these like cool pens and like iPads and shit. I'm just using my mouse.
Me neither. I don't use my fingers, man.
I was using my finger before, and then it would do this. It'd just do like that, like all the time, and then like people would get lost. So like for example, I would do that with double for loop, get all the combinations, and then I would go another loop just to get each one on its own. So then I just get 1, 2, 3, and then I would go. I would return the whole set. So 1, 2, 3. I could just add that. I don't have to do any logic. So I guess you could chunk it. So let me change the color of this. So this would be like 1 loop. This would be 2. I add this, and then I add the empty set. That's how I would brute force it.
Okay, so that's okay. So you're going one loop. So you have let's say I is here. Then you go from I plus 1 to n.
Yeah.
That's one for loop, and then you go a nested for loop, and then inside the nested for loop, you're gonna go another nested for loop.
Wait, what?
So that's how are you gonna? So you have one nested for loop, right?
Yeah, yeah. I don't have to completely embed. I could just go. So it's gonna be 4 I in array, right? And then I'll go if I equals for I in array, if I equals the current number. So I'm gonna have a what's it called? Yeah, nested for loop. So for I, then for j in array. So then I basically say if I equals j, skip, so continue, and then it'll just get all the combinations that aren't itself. So it'll basically get this. So this is check, right? Now I can get.
Hold on. Let's walk through it. So I
Okay.
in array. So let's say I is 0 position. So I is 1. You go inside for j, right?
Yeah.
J will run from 1 to 3. Okay.
Yeah.
So now if I is equals to j, which is 1, you don't do it, right? Okay. So now j is now 2. What do you do? So now I is 1, j is 2.
Yeah, so first I'll do that. So I'll have a collection of things. So I'll have an empty set here, an empty array, I mean.
Yeah.
And then I'll have a set up top that I'm gonna append to,
Okay.
or I'll dot add to, or whatever. So I have this empty array
Yeah.
that I could just put in here actually, because it's gonna refresh every time I go to another element.
Yeah.
So I'll put that set inside this top for loop. So I'll go a temp is this set. This array. Then I'll go. If it's not there, append it. So it'll be. I'll append.
1 and 2. So you're append. You will.
So first there'll be 2 and 3. Yeah. So first there'll be 2 and 3
No. How is it 2 and 3?
because I and J are the same, right? So it'll skip.
Okay. I and j are the same. So you skip.
Yeah.
You
Then it
skip
goes.
this for loop. You skip the entire for loop.
No.
Skip it.
So if I equals J, you continue. So you skip on the inner for loop,
Okay.
and then you just
You skip the entire inner for loop.
the what?
You skip skip the entire inner for loop if I equals to j.
If I equals j, continue. Yeah. So it'll go to the next iteration. So j will now be the next element.
Yes. So j, now your j is 2 and your I is 1, right?
Yeah.
So what do you do now? So now you temp dot append.
Yeah. So I'll go. Actually, yeah. So I'll do this. So since we know I is 1, I'll leave I here already. And then I'll just temp dot append. Temp dot append j.
J. Okay.
So I'll temp dot append the j, and then I will what's it called? That's all I gotta do, and then it'll refresh on its own for the next iteration.
Yeah. Yeah, but what do you see a problem with this?
Uh,
See any problem with this? So I don't even need compiler. I know that there's a problem with this.
temp dot j, ij, you append it.
So you see, I'll direct you. The problem here is, okay, so I will go back to the example, right? So I is 1, j is 1. You don't do it. Now your I is 1, your j is 2, right? So you append I, which is 1 and 2. So now your temper is 1 and 2. Now go back to the loop, right? Your j is now 3, I is 1. What do? You append it again on this temp.
Oh, that's what you're saying. Okay, I see what you're saying. Okay, so after this, after temp j, I will have to add it to the set up top. So set dot add temp, because that gets that combination, and then I will reset.
The temp to an empty row.
Yeah.
Okay, that's good. Oh. Okay, that's good. And now you go to 3. So now your I is going to be 1 again, and your j is going to be 3. You append 1, 3 in the combination. So now you have done your second for loop, and now you go back to your first for loop. Now your I is 2, and your j is going to be 1, right?
Yep.
So now, yeah, so j is going to be 2 and 1. Okay, so it's going to be 2 and 1. And if I is equals to j, which is not, what you do is you add 2 and 1.
Yeah. So it'll keep pairing the elements for all these inner ones.
Okay. Okay, so it's going to go 2 and 1. So now you got combination 1, 2, and 2 and 1 is the same, right? Is that what? Is there 2 and 1?
But that would be a permutation, right? So technically, if I go, would that be the same?
So now you got 1 and 2. Look at their example.
Yeah. So 1 and 2 and 2 and 1 is the same. Okay. So.
But so your set doesn't really work, because in your set, when you're adding a tuple, basically 2 and 1 is different than 1 and 2.
2 and 1 is different than 1 and 2. Yeah. Yeah.
So it's a tuple is different. So now you got 2 and 1, and you also got 1 and 2. So you got 2. You're also going to have 3 and 1, 1 and 3.
Yeah. I see what you're saying. So you can only have unique elements in a unique set. Okay. So let me see this. Given an integer array num of unique elements, all possible subsets must not contain duplicate subsets. Okay, so I guess the whole subset technically would be duplicate, right? Okay. The return in any order. Okay, so if I want to eliminate that, how do I do this? Okay, so it'll be, first I pair everything. So go 1, 2, 2, 1. Will be 1, 2, 1, 3. Okay, so there's an easier way to do this then. Let's scratch this whole thing. So it'll be for loop, embedded for loop still, for I in array, right? And then it'll be so we're not going to do for I in array. We're going to use the actual range component to shift it by 1. So it'll be for I in, wait, I need some space. Let me zoom out here. So it'll be for I in range of 0 to length array. So the length of the array. So this is the length of all the elements, right?
Yeah.
So this is the base loop, and we don't want to repeat anything we've already seen. So I'm going to go for j in range, and I'm going to go I plus 1 to length array.
Okay, alright, you actually don't really have to do this. So if you go back to your old solution,
Yeah.
I'll show you a easier way to do it. I'll show you a trickier way, trick to do it. So in your old solution, you had a problem where you had this, like your set, and you're gonna get duplicates, right? Like 1 and 2, and then you're gonna get 2 and 1.
Yeah.
So in order to avoid that, all you do here is, and so before you append it to the temp, you just run a sort. So 2 and 1, you sort 2 and 1, it's going to be 1 and 2. And now when you add it to the set.
Oh, it doesn't add.
Yeah.
That's smart. That's smart. But doesn't that increase your time complexity?
Yeah, absolutely. So in that case, the time complexity would be.
Because the sort itself is all n log n.
So sort is n log n, but you have 2 nested loops, right? In the worst case situation, it's n squared.
That'd be like n cubed then, right?
No, it's going to be n squared plus, and for every n, there's n log, no, n squared times n log n.
Yeah, it'd be n cubed.
Yeah, so it's going to be n cubed log n cubed times.
I think this way is better, right? This way would be more efficient. You just do nested for loop for, and then you just don't repeat any element. So it's just n squared time.
Okay.
So like.
This will have its own connotation, but this is also still n squared, right? So you do I in the range of the length of j. So basically, you're going from I to run your code against your thing. All right. So when I is 1, your j is in the range of I plus 1 to the end of the loop.
Yeah.
So your j is in the range of this to this.
Yeah.
Okay, so you're going to add 1, 2, you're going to add 1, 3. Now, your I is here, 2. Now your j range is 2 and 3. So you added 2 and 3.
Yep.
Very good. And now, finally, your I is 3, and your range is in the range of nothing, pretty much out of bounds. So you just skip out of it, and then you add 3. Okay, so now you got 1, 2, and then at the end you just add the entire 1, 2, 3 again. Okay, and then you add an empty string, an empty set.
Yeah. So over here, I add that. I add the entire thing. I add the empty as its own standalone, and then I could just for loop one time through all these elements, to get that. So that's O of n squared
Yeah.
plus O of n plus O of 1 times 2.
So what was it squared? Those pluses don't count. Take the worst case situation.
Yeah, no, I know. And then if I reduce it and I add all this, like O of n squared overpowers everything. So it's like O of n squared is the overarching time complexity. I'm just breaking it down like what each piece of my logic would be. Because like I get this way, because I like this way better, because it solves it and it's like it shows the logic of like how you can like do it by the set. But if you go by the time complexity, it does eat up a lot of time if you do the sorting algorithm too, because you get an extra power of n on the n squared here, because it's gonna be times n log n, and then the O of n cubed overpowers the log.
Okay. Alright. Awesome, that's good. Alright. Okay.
Should we go a hard one, like a super hard one?
No, we can do better. This is not.
Oh, we're gonna optimize it.
Yeah, this is not the answer. This is not.
Oh yeah, because brute force is just the base level, I guess, right?
Yeah, this is not the answer. Okay, so you can think of it a little differently, right? One of the ways of doing these problems, if you think of them like a recursive use case, right?
Okay. So space complexity now.
No, there's no space complexity. So if I have two, I can, okay, this data structure is kind of like a tree, right? So basically, we got 3 elements.
Are you looking at the answer as a tree?
No, no. Watch this.
All right.
So you got 1, 2, 3, right?
Yeah.
Okay. So we got 3 elements, okay? So now if I can turn this into a tree data structure. So I can either choose 1 or I don't choose 1. So I choose 1, I put 1 there, okay? And then I can go kind of like in the next level of the tree. Okay, so I already chose 1. Now I can choose 3 or 2 or 3. If I choose 2 or 3, it's 1 and 2. So I can choose either 2 or I don't choose 2. So if I don't choose 2, this goes the other side. Okay. Alright, so if I don't choose 2, it is still 1. And on this side, well, I can either choose, now here, I can either choose 3 or I don't choose 3. So now, I can choose 1, 2, 3, or I don't choose 3, so like, what we got here is, if I don't choose 1, 2, this is 2. Now look at this. This is the result. And this is also a result. 1, 1, 2, 3, 1, 2.
With the duplicate? I guess, yeah. You could either be itself or you choose the other option, yeah.
Yeah, so now if I choose in this one, they're all like fucking puzzles. Like, if I choose 2, and now if I already chose 2, I have either choices. Taking 3.
Yeah.
Or I don't take 3.
There's also another method because that way it looks kind of long, right? Like to conceptualize.
Um, that way, it's not long. It's if you do it recursive, do like the recursion. I think these are called cursive backtracking. I think this is that's is this like a backtrack problem? Who knows? We won't know unless I started coding it. Yeah, this is a backtrack. So every time we're going like one ahead, we're actually backtracking it, and that will actually give you like a optimal solution.
Like in what terms of time and space complexity?
Just height of the tree. So it's gonna be what?
Oh,
Yeah. So
height of the tree. Okay, that makes sense. If we're going by height of the tree, it's just 1, 2, 3, 4 levels. So it'd be like O of n. So I guess O of n height. I was thinking the other way to do it would be because usually one of the techniques for if you have a solution where you have embedded fours, one of the techniques is where you can use 2 pointers and then just slide them this way and then this way.
oh, sliding window.
Yeah.
That's not gonna work here. I mean, you could try it. I don't know. I didn't even know that you could actually do this with formats because I mean it worked. I guess you can try implementing the form loops, but I didn't think about it because so it is like I didn't even think that you could do like a double for loop. You want to go into Replit and then go on Replit. Let's code this up. Let's code up. We code your solution and we code our solution.
Did you delete the other one?
Let's not do the pointer one. Don't do the two pointer.
Okay. Okay.
Did I delete it?
You delete the double for loop one though, right? We'll figure it out. Okay, so we're on here. You want to go to REPL?
Yeah, Replit.
How do you spell that?
REPLIT. You know, this is Naval's company. He knows who it
Replit?
is. Yeah, oh yes.
Is this like Naval Ravikant or whatever his name is, or how do you say his last name?
Ravikant.
Wait, why doesn't it show his name as the founder?
No, he's not a founder. He's the angel investor.
Bruh. I remember you talked about him one time, and I went to his Twitter profile, and all it said on his profile is like, my favorite button is the block button. I'm like, yo, that's what Will Smith said too.
He's a modern philosopher.
Is he?
Oh yeah, have you seen his thing for? Have you seen his podcast with Joe Rogan?
I didn't watch it. No.
Yeah, it was really amazing. And then he also has he's a big deal in Silicon Valley. So
Yeah. How do you use this thing?
yeah, just log in.
Okay, let's use GitHub. I'm gonna authorize it. Build software better.
Naval. Ravikant.
Meet your new starter plan. 3 repos, public
Yeah,
only.
just you don't even need that. Just create a repo. Create Python. Yeah, create Python.
Oh, Python.
Yeah, just create Python. Yeah, just create a repo. And now we can share. And then we can vote. So
Oh, it's a team workspace. Okay.
by the way, on Google interviews, or no, you have to share like somewhere here. Like maybe it's public. Just give me the link. Yeah, it's public. Yeah, in Google, you actually do it on Google Sheet, basically. I think. And Facebook, they were using this ID called, it's not even ID, it's just like text, a very minimal, cannot run any code or anything, it's called CoderPad.
That's why they use like Google Docs like for Google. It's like because it's basically Notepad.
Yeah. So like if it's Google Docs, man, like I am like I know that I'm gonna get the job because I'm gonna run the code, just explain and get the fuck out of it. And bro, like this one, like if I see the question and I'm like, oh, this is a recursive backtracking problem, and if I say that within like the first 2 minutes, they know that I'm their guy.
That's wild, yo. This guy's giving the fucking secret sauce. Like,
Bro, let's just tell them like what's the optimal solution, and then like there's no need to. The rest of the interview is just formality.
I remember when I got rejected at Wingmate, I passed the guy's challenge. I did C++ and I used pointers and a linked list. Double pointers, the rabbit in the hare where you have to go, one goes faster than the other to check.
Yeah.
And
rabbit
then
and the tortoise.
oh yeah, I said rabbit in the hare. I'm like, what the fuck? They're both fucking rabbits. Yeah, rabbit and the turtle, or whatever the fuck it is. And then yeah, so like I ended up passing it, but the guy was like,
swear on your podcast, bro, we're gonna get demonetized.
it's fine, it's whatever. Bro, I want this to be like proper, like normal people swear, bro. That's like legit. Like one of my boys was saying too, he's like, yo, why don't you just like solve all the questions first and then solve it again on video more efficiently? I'm like, because that's not reality.
Yeah, that's true.
The average guy watching this is gonna be like,
Give me
the fuck.
access. Yo, give me access. Like, what
I
is
did.
this? You just send me. You did.
I put it in the chat.
Yeah, but it doesn't let me write.
How do does it give you like a notification, or how do you?
No.
Oh, public. It is. It's public.
Hold on. Let me see that. Let me see. Rebel Naval made a.
Bro, Naval's gonna add some copy link, bro. Naval's gonna add copy link to his fucking.
Yeah, look, make a private join link.
Alright, let's do that. Okay.
I'll send that.
Shout out to Naval.
Don't shit talk my boy Naval. You got us covered. It's free tools.
For free tools that you gotta make private. But it's nice that he got the AI thing to ask for help.
Oh yeah. It's really awesome.
That is the fucking. This is where the money's at, because like, this is where Leetcode fails and Algo Expert fails. They don't have an AI console helper, so you can get unstuck on your own.
Yep.
And then boot.dev does it really well actually, because they limit their AI's help. It doesn't tell you the answer. It like tries to force you to think about the answer. The AI model.
Okay, so how do we do this? Okay, so we're gonna have like a result and a solution.
Oh, you writing the test?
Huh?
You writing the test?
Yeah, this is our thing. Let me copy that. Let me copy the description. The jig.
We don't run this, do we? Or does this run too?
No, it does run.
Fuck.
This is the same thing. He's running this. So his AI is Llama 3, and this is a work container.
Oh, this is that llama stuff you were talking about?
No, his AI, Ripple's AI is actually Llama. Llama is a model. It's a base model.
Yeah.
Yeah. And okay, I'll tell you something about models offline and machine learning models.
Alright.
And yeah. Anyways, can't say it on the stream.
Okay.
I'm gonna post it. I don't want to make you.
Bro, last time I had a chat with you, I had to comb through all the minutes to delete the parts that you mentioned.
Yeah, that was not fun. I know, and people still got mad, bro. Like, yeah, investors and
I guess that's what happens at that level, right? Like people are always watching you now.
Yeah, I kind of hate it. Just want to code, man. I want to fucking do this bullshit. Anyways, all right. So yeah, you can try your solution. Go ahead.
So for I in 0 to when nums. Oh no, we just did I and j, right? So it's just gonna be for I and thing, and then I'm gonna create a temp. I'm gonna create a set. So store equals set. This is a set in Python. This is gonna be temp, and then it's gonna have I.
Why temp I?
Temp equals
temp I, like the I. Yeah. Okay. Yeah. There you go.
I, and then I could even delete this. Goes to len nums. Then actually, I don't even need to do range. I could just do the elements. Just add that to. The only thing is, I don't know if Python will allow me to add it just as is, but let's just do it that way.
Don't worry about the syntax.
Okay.
Yeah.
Syntax really fucks it up like a lot. Okay, so
Yeah.
spry nums temp. So right now it's our first for loop for j in nums as well. If I.
Yeah, if people failed you because of you couldn't remember syntax, yeah, trust me, you don't want to work for that company. That company is probably bullshit and too much drama.
Yeah, dude, like I scored 100 on their Python. They asked the exact same questions in embedded C, and I was struggling to find the syntax because their software doesn't let you look anything up. So I was just like, I was manually doing logic, like with fucking and like this, and like fucking I had to go back and get my curly brackets, fucking semicolons everywhere. Like that shit took so long, and I just ran out of time. Okay, so if I equals j, continue.
Yes. A Waterloo-based company.
I think so. I think they're in Markham.
Yeah, I also hate those guys. The Canadian companies are so shit to work for. I'm just saying.
I'm starting to realize, yeah, all the American companies pay well too. Why is this thing like auto answering?
Yeah, it's because the AI autocomplete is up. It's okay. You can turn it off if you want.
How do you turn it off? It's like.
Yeah, I just did.
Okay, cool. Oh, nice. Okay, so for our thing, so then for j, if I equals thing append. No, I don't want to append it. Why the fuck is it keep showing that? Okay, dude. Oh my god, this thing's like throwing off my brain. Is there a way to turn off that autocomplete?
Yeah, just go onto the bottom of your screen. There's Python and there's AI. Hold on, I'll show you.
Oh, AI.
Watch this. You can do this in Slack. Like, right here. Where is it?
I just disabled it.
Okay, yeah, just disable it.
Okay, so for I nums temp I, for j nums, if I is equal to j continue, then I want to go. If I is not equal to j, then I want to go temp dot append j. So then now I have my pair. Then I want to go to the. Oh wait. This is the first solution we did, right?
Yeah, this is the one with the sort.
That.
Yeah.
That's the n cubed one, right? Okay, fine. We'll just do. Okay, so then. Okay, I guess we can go.
It's actually not n cubed because it's actually still n squared because your sort is outside of the second for loop. It's still inside the for loop, first for loop. So it's actually n squared still. So just do sort and then, and then append it into your set. Define your set.
No, it would be inside.
No, it won't be inside. Would it be inside? No, it wouldn't be inside.
Because you have to go to all the elements of j, right? it would go through 1, and then you sort it, add to the set, then you repeat J.
I see. Yeah, you're right. So yeah, it is include.
Well, let's just go. I guess go through the logic. We could do the other way after, or whatever the fuck.
Okay.
So sort it.
Yeah,
So sort you could just do as is because it's a standalone function that is built in, and then you can go temp.
no, just do.
Yeah, temp dot append. Oh no, the set dot append. So stores dot add temp. Then you reset temp.
Yeah, and then keep doing that for many times, and then okay. So now print your stores, and then run the.
So first, yeah, let's print it. Let's print stores. So then we have to see what's missing because we have to also add. Actually, I can do this at the beginning too. Set or stores dot add the empty set and then the complete set. So stores dot add nums.
Okay. That's not how you do it.
Or are you just doing 2 lines?
Yeah. What a lazy fuck.
I know.
Just write it down, my guy. Oh my god.
I'm too lazy.
Disqualified. You know, this is I'm gonna, if you do this,
The guy's like, yo, this guy wants to make 6 figures, he can't even type a fucking line.
what a guy.
It's actually hilarious. Okay, and then now that I added that, I'm gonna do a for loop up top for I in nums, and then I gotta add each element individually. Stores dot add I. Let's print stores, run it.
Okay, what's wrong?
Stores dot add. Oh, the empty set.
You can't add an empty list. Unhashable type list. Okay. Let's make it a string. Make that empty list a string. Yeah, and then in the string do the bracket. Yeah.
Well, it doesn't auto-complete the brackets.
Okay.
Stores dot add nums. Okay, it's the same thing with you can't add the entire array.
Yeah, so make it like nums to string or something like that.
Oh, I could just do this, right? I could do a Python f string and then just dynamically add it.
Yeah.
And then I could just go nums now, and then I'll do this. You could do the same thing here.
No, don't do the same
Okay,
thing.
it's not worth.
Yeah, just run it. Right.
List. Unhashable type. Oh, because I'm doing it here too. Okay, so then all I have to do is the same thing. So I could just go Python. Okay, so I go append, sort, add temp. So then I just add brackets, and then f string it, and then dynamic. That should work.
There you go.
Okay, so we got 1, 2, 3. Oh wait, nums has to be in
Brackets.
brackets.
Yeah, do the brackets, yeah. No, brackets out, yeah. Yeah, no, you're right. You're right. Yeah, brackets outside, just like that. Yeah. Now we run it. See, dupes.
Wait, what? Why does it do that? It doubles up the array, like when you don't do it.
No, it did it. It's just for all, you gotta make everything a string, basically. So on line 30, make on line 20.
Oh, append J?
Yeah, append also do have string. Just like.
Oh, you have to add them all as strings. Okay, so just like turning the entire question to strings.
Yeah. Minor, but I got the idea. Like these are. came up to, like, if you're this far and the guy still doesn't give you a job, he's an asshole. It's just, or there's no job, bro. They're just farming your personal information.
Yo, some guy actually did that to me. The guy was asking me my favorite Pokemon and shit after I was on fourth stage interviews. He's like, oh, so what's your favorite Pokemon? I'm like, Gengar. Oh, good choice. Mine's Alakazam, by the way. Yeah, I'm never gonna call you back, but like, it's like, yo, what the fuck? Yo, the fuck? They made me go through like 4 stages of the interview. I did like a coding exam. I showed them my portfolio, my projects, because I actually built projects because the freaking leak coding wasn't enough, right? So like,
Yeah. Oh my god, they made you do projects and to give you the job?
yeah, they made me demo it too. They're like, oh, we'd love to see your Pokemon app. I'm like, all right, see it.
Let me guess. Canadian company.
Yep,
Yeah.
Canadian company. And then I talked to a friend and she said they've been like, what's it called? They've been having that job posting open for the last like 3 years, and they've just been interviewing people and not hiring anyone.
Yeah. Dick move. But anyways, I like, you got it. Like, this is good. This is a good solution. You're like, a solution doesn't always need to run. It's a good solution. All right, so this is O of n squared, but let me try mine, right?
Oh, you're trying the tree method?
Yeah. So it's called what is it called? Recursive backtracking, I think.
Okay.
So, alright, and E track. Okay. So, I need a backtrack method that has I, and my I, where's my nums? Okay, got nums, right? Right here, I got nums. Okay, so I know my recursive termination case would be if my I JavaScript, man.
Oh, you're doing in JS?
JavaScript. No. Like I got into the habit of doing too much JavaScript. That's why I just write it like that. And if my I is greater, that means I ran out of number. So I'm going to return. Before I return.
Oh, so that's your base case?
Yeah, that's my base case. So now, what am I going to do now? So, okay, so let's run btrack from 0.
Why do you check if I is greater than numbers? Are you checking I in terms of the levels?
Yeah, so I would be, if I is greater than numbers, that means we don't have any more numbers left. So I'm going to start from I equals to 0, which is 1. And then I'm going to pick either 1. And then I'm going to not pick either 1. And then I'm going to go down the tree recursively. So what I'm going to do here is I'm going to do sol dot append, and then I'm going to do nums of I. And then what I'm going to do is I'm going to do btrack recursively, and then I'm going to do I plus 1. So it's going to go to the next one. And then I'm going to actually backtrack from there. I'm going to do sol.pop. So this is like the position when we don't choose the number. Choose number, and then we do btrack I plus 1 again. And once you are done with this, we can just do res.append sol. And now if I print res, oh shit, forgot to do another thingy. Alright, let's clear this. The fuck? How did I clear this? Okay, clear. Run. And it didn't. Wait, what? Uh, it gave me all. It gave me all of those. You see, if I run it, it gives me all empty arrays. I wonder why.
Because Sol's an empty array.
No. It's because this Python is stupid. You gotta fucking copy your, otherwise it will memory hog it. So I have to actually copy. Yeah, I free up the memory and copy it. Copy the Sol, and then I put it.
Oh, you have to what's called it's like implicit and explicitly.
Yeah, I don't know. They call it closure. I think in JavaScript.
A clone.
Call it in Python. But yeah, this is the most optimal solution. So this is just gonna be the length of the height of the tree, and height of the tree is.
How'd you learn recursive backtrack?
Yeah, it's just like, I think you've about it.
O of 2 times n? You said you put O of 2 to the power of n?
Yes, because you got two choices. So this is your choice to include, choice to not include. So that means you always have two choices. And you always need to, and n is the number of elements that you have. So n to the power 2 to the power n, which is slightly worse than n, I think, log of n, because it's a log of constant number to the power n.
No. That'd actually be the opposite.
Really? Okay.
Yeah, because 2 to the power of n is the inverse of log base 2n.
Okay.
So that's like almost exponential.
Hold on. There's a big O graph of performance.
I think what you're trying to say is it's O of log of n base 2.
No, dude. Log of n is slightly worse than. This is slightly worse than O of n. Like O of n would have been like a fucking awesome solution, but this is not. This is slightly worse than O of n. Because.
Oh, unless it's O of n log n.
Yeah, because. Okay, hold on. So if I go to like a graphic tool of some sort, go to Wolfram Alpha or something. Yeah.
Bro, I haven't used Wolfram Alpha since UIT.
This is amazing. I love doing math, so like I love doing all this crap. Now do
Plotting graphics.
2 to the power n. Yeah, do 2 to the power n, and then do
Plot a function? Yeah.
Yeah.
So let's go plot 2 to the power.
2 to the power n. Hold on, let me generate that for you. Where is my? I have like this app for doing math. Fuck, I'm such a nerd, man. Weird.
See how it's like exponential? This is 2 to the n.
There's Wolfram Alpha and ChatGPT nowadays. Sick. Okay. But anyways, I'm just gonna share my. So I use another tool for data science. It's like a R library. Remember when R was like a data science?
I don't know who uses R now. Like, I know everyone got into like freaking like Excel and shit, and that's why they got into R.
Yeah. Data science people.
Yeah, the data science people use R, SQL, and Excel together. And they're just like, like overemphasize how important SQL is and everything.
Yeah, that's the reason why it's hard to drag people to outside.
Yeah, it's hard to get people to serverless.
Yeah. Yeah, plot those two and let's see how it works.
Yeah, see?
Okay.
This is what I'm telling you. It's exponential. And then, what's it called? You go of plot n. Okay, so that's just going to be a straight line. That's not even close, though.
Yeah. See that? So this is slightly worse than. Is there like another?
No, this is not slightly worse. This is like exponentially worse.
Yeah. So this is your parametric plot.
Do you want to look at this plot, not parametric? Because parametric is the I think inverse.
Inverse of it. Yeah.
This is O of log of n.
No, that's not. Go down. Go down. Go down. Okay, just plot log of n. Don't plot the other one.
Yeah. Okay. So.
Log of n. Yeah, just delete the first one. You're still plotting log of n. Okay. Yeah, like, is there no way to kind of?
What if I do this? Now it should know this. See, this is what I'm telling you.
But this is log of n.
Yeah.
But you're not doing this is log n. You have to do big O of n. So there's no log. So you're just gonna get rid of the.
No, I mean when you use a tree-like structure, right?
Yeah.
Because you're cutting. Okay, so when you
No. That's where you're wrong. So when you do a binary tree, only then it's log n.
yeah.
But this tree, it's a recursive tree. So you still have to go to all the.
Yeah, so I'm saying yours would be inverse of that, is what I'm saying. So it'd be.
No, it's gonna be O of. I'm pretty sure this is.
Okay, I'll show you on the whiteboard. Like so 2 to the power n
Yeah.
equals x, right? So then if I want to get log of x base 2, that's n. It's inverse. So yours is the exponential one. Like the binary search thing would be like the inverse of that. It would be like halves.
Yeah, that's what I'm saying. Mine is not as performant. It could have been performant. So, okay. Log of n is linear function. Log of.
So that's that.
To the power n is exponential function.
Yeah.
So mine is pretty bad, actually.
Actually, we should compare yours 2 of n, plot log 2 of n, with n cubed. I'm pretty sure yours is bigger. That's the one thing I'm curious about. So it'd be.
No. Look at this. Look at this chart. This is like from textbook.
N cubed.
I can send it to you.
Actually, you see that? You see that? At 20? It's at 8,000, right? And then let's see log of 2 of n at 20. Look, yours is like exponentially worse than the n cubed.
Yes. So you get to do like a dynamic programming. If so, you get to do a DP on this DP caching. If the numbers are really big.
Yeah, like this is like the worst case scenario actually. Like if you get to a 2 to the power n, because that's exponential. This is actually slightly less worse than this, but this is still like worst case scenario, n cubed. You want to avoid anything n cubed or exponential. If you get like a good one, it'd be so constant time is O of 1, where you get a flat line. O of n is where you get your slanted line. This is like this is like happy path ideal. This is like Fantasyland. Pretty much barely any solutions will have an O of 1. But O of n is like kind of achievable. Then you get n log n, which is your sorting algorithm, which is like kind of like this, but it's like that, trails upward. So log n trails flat to a certain point because it hits an asymptote. N log n trails upward over time.
Can you put this in GitHub and ask it like what is the most optimal solution? Sorry, not GitHub, and
ChatGPT, yeah. Okay, so let's. Where's the question? Give the link. Subsets.
Yeah.
That's what I do at the end of all my videos. I just see if there's like a better way on ChatGPT, and then I learned from that versus what I did.
Yeah, put it in and then ask it like, what is the optimal? Don't ask it to solve it. Don't ask it to solve it. It's
Okay.
Trash. Yeah, just put in the question, and then paste the question, and then ask, what would be the most optimal solution, and what is the runtime of it? What is the big O runtime of it? So that, time complexity. Yes.
I actually learned everything about time complexity from ChatGPT. I got it to explain each line to me after.
Yeah, he's doing backtracking.
Okay, they use backtracking, but maybe the way. Let's see.
Can you close that dumb message?
What the fuck is that? Yeah.
Fuck, man, I hate that.
Okay. So it says the problem needs to generate all possible subsets. Okay, cool. Use backtracking. Okay. Subset recursively. Start with an empty subset. Build subsets by including or excluding. Okay. Initialize an empty list. Find a recursive function to backtrack. This is what you did.
Recursive case, yeah, look at that. That's the same.
Oh wait, O of 2 of n.
Yeah.
All the subsets take up the space.
And what's the time complexity?
O of 2 of n.
Yeah, O of 2 n, yeah. And this is the best case you can do.
Wait, I want to ask it this.
Can you do a recursive solution, and what is the time complexity of it? No? Okay, recursive. Why? Oh, sorry, iterative solution. We misspoke. He's just gonna do like not a back.
Okay, so I'll just kill it. What if I put in this? What if I put in our... Wait, I want to go back to here where we solved it.
Yeah.
Because technically this would run in a better time complexity. If we go by what we saw in Wolfram Alpha and here.
No, I don't think so, dude. I think O of n cube is worse than 2 to the power. Is it?
No.
Who knows, man? Okay.
What is the time space complexity of this solution?
And is the solution correct?
So cosine is an attempt. Let's analyze time space complexity.
Issues with the code, so that's probably
First loop n. Okay, so it's breaking down space complexity. So we get O of n squared, O of n cubed. Yeah, so O of n cubed, like we mentioned. O of n cubed. Oh, space complexity. This is where it fucks up. So this is why your solution's better. You know why?
because the space complexity is n times 2 to the power
N times the exponential, which is fucking insane.
Yeah, so it is it's an extra n. Okay.
The optimal approach would be backtracking, which would have both a time and space. So optimal method for both, well, in general, would be the backtracking because you get equivalent time space complexity. Whereas this, I think you get a better. Let's ask it. Is O?
Can you do better than O of 2 to the power n? Just ask it. What is the best time complexity, and what would be the algorithm for it?
Okay, I just want to check. Grow relative.
Yeah, so for some time, so if
See
you go
that?
over like 20 iteration, then O to the power 2 to the power n is really bad. You see that? So
Yeah.
if you go, but you have to like, how would you do it without the space complexity of n to the power n? 2 to the power n, that's
How would you do without the space complexity?
yeah, so that, I don't know, because this is, I thought this was like the 2 to the power n is the best time complexity you can do, but let's ask it. Like,
Okay,
I
what
don't
are
really
we
trust it, but let's see.
what are we trying to ask?
Can you ask ChatGPT what would be the optimal solution for this problem? Can you do better than 2 to the power n? And then, yeah. No, I don't think you can do.
Can we do better? No.
You cannot do better than 2 to the power n. Yeah, this is it, man. Like I'm kind of. I remember this. You cannot do better than 2 to the power n.
There are situations like that, right? Because
Yeah.
the other thing is, with recursive solutions, you always have the space complexity factor because it eats up call stack.
Yeah.
So like whenever you want to like for in terms of humans reading the code, recursive is the best. But in terms of like the actual thing, you want to try and be iterative as possible with like while loops and shit like that, so you don't eat up call stack.
Yeah, but while loops are not as good when it comes to. It depends on your program, right?
Yeah,
While loops are not as good.
the recursive method is more intuitive because it's based on the mathematic principle.
Yeah.
The while loop is just
Functional programming.
yeah.
See, this is okay. Stop the stream. Let's shit talk.
Okay, right here. All right, guys, that's Shadid and the stream. I'm gonna end here. Kaneologist out.